Okay, so B5, we're adding, subtracting, multiplying, and dividing rational expressions. Okay, and we'll start off with something that I hope everyone remembers how to do. If I have 1/2 plus, let's say, 3/8, and I ask you to tell me what that is. Anybody? What would we do first? Yeah, just go ahead. Pavlos.
Multiply the first fraction by 4.
So you just know by looking at that, oh, I got to take a 4 to the first fraction, right?
Yeah.
What does that give us? 4/8, so you guys know that it's 4. What you do to the numerator, got to do to the denominator, and vice versa, so that this still has a value of 1. What we're doing is multiplying by 1, so it doesn't change the value of the fraction. We get 4/8 plus 3/8, which is 7/8. Everybody remembers that, right? Okay. Now, not that you would think to do it this way, but one way to explain why you need 4 there is if you actually split up 8 and factor it. 8 is the same as 2 times 4, right? So looking at the fact that this is a 2 and this has a 2 and a 4, what's missing? That's it. So it's whatever's missing that you need to multiply to the other fraction, right? Okay, so using that same philosophy, let's say I have something like 3 over x squared minus 5x plus 6. Let's do minus x over x squared minus 9. Unlike the 2 and the 8 where we just know, oh, just throw a 4 into the first fraction, can we just kind of know what to multiply by looking at it right now? So what can we do? Yes, good. So first we're going to factor. And talking about the denominator here, right? So factor the denominator. So we get what here? Good. And then what about x squared minus 9? All right. So playing the same game, do you see anything already common to both? The x minus 2 is good. We don't need to worry about it, right? But the first fraction is missing what? What do we need in the first fraction that we have in the other one? X plus 3. And what do we need in the second one that we have in the first one? X minus 3. Good. So these 3 factors in the denominator, that's our new lowest common denominator.
Maybe x plus 3x minus 3.
Oh, whoops. You guys said that, didn't you?
I said minus 3.
I don't know why I wrote minus 2. Okay, so that changes things. Thank you. So this needs an x minus 2, right? Because x minus 3 was already part of both denominators, and we're missing x minus 2. Thank you. So just like we did at the first fraction, we're going to multiply the numerators now. Here we got 4 and 3, then we combined them to get 7. Here we're going to have a little bit more work to do, but they're all going to have the same denominator, just like this answer here. So I'm going to write the denominator down first. And now I'll go ahead and multiply this together to get what? Three x plus 9, good. And now here we have a negative x that gets multiplied. So what is that going to become? Uh-huh. Good. So after we figured out it was 4 and 3, we combined to get 7. Here we're going to combine our like terms and see where that takes us. So we have negative x squared plus 5x plus 9, which does not factor. So it looks like we're done. So this would be your final answer. Now, if possible, this numerator, you want to check and factor if possible. So if possible, you want to factor this numerator out, because sometimes you might get something that's common to the denominator and you can cancel it out again to get an even simpler answer. In this case, we didn't have anything that happened, but you do want to always get in the habit of checking. After you combine everything, just check again to see if there's anything else you can do. Okay? So that's adding and subtracting. Are there any questions on that particular question? That example? Okay, before we do multiplication and division, here's a convenient trick. Well, it's not really a trick, but if you have something like, let's say 2 over 2 minus x plus, let's say, x over x minus 2. One option would be to multiply the first fraction by x minus 2 to the numerator and denominator, and then do the same thing over here with 2 minus x, but you don't have to do that. These denominators are almost the same, they're just flipped around, right? In fact, this 2 is positive, where in the second one it's negative. Here the x is negative, here it's positive. Not only are they flipped, they're exact what? They're exact opposites. Okay, so if you see that these are opposites, you have a couple of options. You could make one into the other by factoring a negative out. So if I pull a negative out of this bottom fraction, bottom denominator rather, this x becomes negative and this 2 becomes positive. And I know this is a goofy way of writing it, but what's this really if I rewrote it? It's the same thing as 2 minus x, right? So now the denominators are the same. Oh, that was fun. I didn't even do that intentionally. What do we get in the numerator? And then the denominator is already 2 minus x. So in this case, the answer is 1. Because they're the same, right?
Where does the negative go?
Where does the negative go? Are you talking about this negative that I factored out?
Yeah.
Okay, so really, if I broke it down,
Oh, okay.
I factor out the negative first, like this. Does that make sense?
Yeah.
And when we're adding a negative,
Yeah.
it's the same as just subtracting.
Alright.
Yeah, so it's there. Any questions on that? Okay. Then let's go to multiplying and dividing. Two basic steps here. First step is going to be the same as adding and subtracting. We factor. And lastly, we cancel. That's it. So, again, we'll do easy examples just to make sure that the concept sticks. If we have something like x squared minus 8x plus 12, let's say over 3, let's say we have times, let's say this is 9, let's say this is x squared minus 4. I changed my mind. minus 16. Okay. Who can factor the first fraction for us? Go ahead.
X minus 6, X minus 2.
What about 3? Can we factor that? 3. That's good. What about 9? Some would argue just leave it. I also argue, well, you could write 9 as 3 times 3. You don't need to, but you certainly could. What about x squared minus 16? X plus 4, x minus 4. Okay? Now, the best way to do this kind of problem is, once everything's factored, just pretend this is one big fraction. Anything in common with the numerator, anything in common with the denominator, those cancel out. So in this case, what's the only thing that cancels? One of the 3's. So then we have a 3 left in the numerator, x minus 6, x minus 2. And in the denominator, we have x plus 4, x minus 4. And that's it. If more cancels, more cancels. If not, then we're done. What happens if this is division?
Switch it.
What do you mean switch it?
Turn other
It's reciprocal. Good. So if we're dividing, we change to multiplying by what? Reciprocal. Good. So I'm not going to do one of those. I'll let you guys practice that on your own here in a few minutes. Same technique. If it's division, make it multiplication, flip the fraction, and then you factor and cancel. Okay? Any questions on that? Yes?
Why don't you change one side to the reciprocal, right?
Yes, it's just the one that you're dividing by. Excellent question. So only the fraction that's being divided by is the one that you use the reciprocal for. All right, last kind of question is called a complex fraction. They're not that terrifying. They look harder than they are. A typical complex fraction problem looks like a fraction or several fractions on the top, and then maybe 1 or 2 fractions in the denominator. So something like 5 over x squared minus 9 plus x over x minus 3. Let's say we're dividing by 2 over x plus 3 plus 1 over x minus 3. So there's a couple ways that you can do this. I'm going to show you what I think is the fastest and simplest way to do it. Okay? First, factor the denominators, the little ones. So these are all good. The only thing that we can maybe split up is this x squared minus 9, right? So that's x minus 3, x plus 3. And now what you do is look at all 4 denominators. What do you see in common? They all have, well, not all of them, but most of them have x minus 3, and some of them have x plus 3. Does that account for every single one? That includes, this out here covers every denominator, right? This is actually the least common denominator of all 4 of the little ones. Okay? And the easiest way to simplify this is to take this least common denominator, multiply it to the numerator, so distribute it to the top, and also to the denominator. So as weird as this looks, technically we're multiplying by 1, because you're taking a numerator and multiplying it by that, taking a denominator and multiplying it by the same thing. So it'd be like saying, let's take a fraction and multiply by 2 over 2 or 3 over 3. So it doesn't change the fraction, it just makes it look different. Okay, so now the point of doing this, if you try to visualize x minus 3, x plus 3 over 1, so this times this fraction, what cancels? Maybe let me write this down one time. If I wrote what I'm actually doing, when I take this denominator, the LCD, multiply it to the first fraction, here's the calculation that's going on. You guys see that? What cancels? X minus 3, x plus 3 cancels. What's left? Just a 5. You guys see how we're getting that? Now let's try that with the second fraction. The second fraction, what's going to cancel out? X minus 3 cancel with x minus 3, leaving behind x and x plus 3. Do you guys see how I'm getting that? If not, say so. Okay, let's try the denominator. What's going to happen if I take that same thing and multiply it to this first fraction here? What's left over? 2 and x minus 3, because the x plus 3 will cancel with x plus 3. And now with the second fraction, what's left? 1 with x plus 3. Good. So we've gone from a complex fraction to something that's not complex anymore. The only thing we can do is combine some like terms and then go from there. So in the numerator, we get 5 plus x squared plus 3x. And then in the denominator, we have 2x minus 6 plus x plus 3. So if we clean things up as much as possible, I don't see anything really happening here. Well, we get 3x minus 3 in the denominator. Can we factor either of these? Can't factor the top, right? The bottom, so you have an option. I'm going to say this is optional. The option here would be to take out a 3 and then write it as 3 times x minus 1, but I'm saying that you don't need to, because does this cancel with anything? It doesn't really help you, and it's just there, right? So you can leave it as 3x minus 3, or if you always get in the habit of factoring but it doesn't cancel, you don't have to like redo it and multiply it out. You can leave it however you want. Okay, but if something were to cancel, you need to make sure that you do that. Okay? Are there any questions on this? Okay.